Yes, sir.
Yes, sir.
Am I audible, guys?
Yes, sir.
Yes,
Yes, sir.
sir.
Good morning.
Okay. Thank you. On the behalf of FDP, I would like to welcome all the participants for this particular meeting. Basically, today we are going to talk or have a discussion about one of the, not the latest one, but one of the technology which has been there into the market from the early 2020, from the early 2000, and it has been there still in the market, and it is actually dominating in the developing countries as well as in the developed countries. So if there is something which is still in dominating position in the developed countries, there has to be something in that particular technology. So we are going to have a discussion about that particular thing. Kindly do let me know if there is any sort of the problem with the audio. Categorically, I have kept my video as a off because ultimately the video is going to consume much more bandwidth. So how many participants we are expecting for this session?
7 participants.
Sorry,
7.
7.
Yes, sir.
Okay, it's still 6, I guess.
Yes, sir.
So should we wait for another couple of minutes or should we start?
We have to wait for 1 to 2 minutes, sir.
Okay, it's 11:31 in my watch. So we are going to start by 11:35. Is that okay?
Okay. Okay, sir.
Yep, thank you. So guys, should we start? Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So hopefully whatsoever we were expecting to have in this particular meeting, we have these to that limit of the participants. On the behalf of LTTC, I would like to welcome you again for this particular session. And today we are going to have a discussion about the copper-based broadband access technologies. So yesterday, if I am not wrong, yesterday you have already gone through the broadband network and its component and a few other allied things. Are we connected, guys? Hello? Hello?
Yes, sir.
So yesterday, what was the means which particular session you have been through? I guess it was somewhat like the broadband network and its component, if I'm not wrong. So yesterday only you have just went through one of the definition. What do you mean by the broadband and what is the definition in India? In respect to the India, as per that type, what we are going to term it as a broadband and what exactly the broadband is. Sometimes whenever we are talking about the broadband, we usually talks about an internet connection, whereas the band is always pertaining to certain frequencies. So isn't it like a dichotomy that we are talking about the internet and we are talking about the band of frequencies, isn't it? So why we are going to talk it? Why we are going to say it as a broadband? Why we are not going to say it as a narrow band or something other? Likewise, the high-speed internet connection. May I know the background? Maybe you are the esteemed teacher from one of the institutes, if I am not wrong. Hello.
Sir,
Hello.
your voice is breaking.
Okay, why voice is breaking?
Yes, sir.
Is that okay now?
Now it is okay.
If I'm not wrong, you people are from a very esteemed institute. You are basically the faculty members over there.
Yes, sir.
From which institute, sir?
Guru Ghanshidas Vishwavidyalaya, Central University.
Okay, Guru Ghasidas Vishwavidyalaya, Central University. Okay. That is, I guess, in Chhattisgarh.
Yes, sir. From
Okay, thank you. So why we are going to talk it about like was a broadband, and whenever we are going to mention it as a broadband, we are mentioning about the high-speed internet. So why we are not going to talk it about it as a high-speed internet? Why we are using some of the other word which may get us confused, isn't it? It's the first question for you to think. By the end of the session, you will get all such kind of the answers. So myself, Alok Tyagi, working as an SD in broadband faculty over there at the LTTC. And I would like to welcome you again on the behalf of LTTC. So let's dig deep into the technology bit. I guess there is something is going on with this PC. So what the agenda we do have today? First of all, we are going to have an introduction about what the technology is all about, why we are using this particular technology, what are the different components of this particular technology, and if technology in there in the market, then definitely the competitors are out to be there. What are the different competitors and why the competitors is still not able to surpass it? Then we are going to talk about this XDSL. XDSL basically stands for all the available flavors of this DSL technology. The DSL technology stands for the digital subscriber line. Okay. Then we are going to have a discussion about the broadband over power line, the cable broadband, and the Ethernet broadband. because these three are the main components or the main drivers for this DSR. They have the intention to replace it, but they are still not able to do that. So what would be the reason? Before it, whenever we are going to start anything, whenever we are going to study anything, whenever we are going to put whenever we are going to work over any of the product, then definitely we should check whatsoever the idea we are working, whatsoever the subjects we are working, whatsoever the product we are working, whether it would be feasible. And if it is feasible, if it is technically feasible, that time whether it would be embraced by the market or not, whether the prospective customer is going to embrace it or not. If it is bound to be embraced by our prospective customer, then definitely our product is going to be the super one. Our technology is going to be the super one. And what are the different criteria or the yardstick for the technology or for the product to be accepted by the market? So the first yardstick or the first criteria is it has to be super user friendly. And why a product or the technology has to be super user friendly? Just because of if we are going to talk about the third world countries, or if we are going to talk about the developing countries, more or less the developing countries do have the same kind of the atmosphere like we do have back in India. So if we are going to talk about back in India, over here, what would be our literacy rate? According to 2011 census, it would be around 74, less than 74. So as per the unofficial data released by the NSSO for this 2021, it would be somewhere around 75%. So still, if we are going to talk about, or if we are going to design a product or the technology for our complete population, so we should take care about those 25% who are supposed to be the illiterate. And what the yardstick as per the government of India we do have for the literacy, that is a person who is able to identify the letters. I am not concerning about the word, I am concerning about the letters. So would be able to identify the letters and would be able to write down his or her name in his or her mother tongue. That's it. That particular person would be termed as a literate. So whenever we do other such kind of the criteria, it means such kind of the relaxed criteria for a person to be a literate person. And still we do have the 25% as per the government of India report, that these 25% out of 100 is not able to even identify the letters. So how I'm going to design a particular technology for them, or how may I suppose that if I'm going to design an interface which requires a certain kind of the literature, the certain kind of the understanding, that particular person is going to do that automatically. So ultimately, if I am going to design a solution for the product or the technology only for the 75% of my population which is supposed to be illiterate, then definitely I am losing out the 25% of my prospective customers, isn't it? So wheresoever I was supposed to have the 100 customers out of the market, still I am losing the 25 at ab initio. I haven't done anything yet. I am just in a planning condition, and in the planning, whenever I'm going to put that my GUI would be look like this, or my application would be look like this, then at that particular instant, I am losing my 25 customers. So keeping that in view, just to serve the complete nation, just to serve the very person who is just the marginalized person in the particular marginalized world, in this particular marginalized society, means the last person of the bench. If we don't have the intention to serve the last person of the bench, then definitely our product is not going to survive in the market. Because ultimately, if we are going to design a particular product to keeping a particular microscopic group in view, then definitely as soon as that particular microscopic group is going to get away with the problem to which we are providing a solution, then definitely our product is bound to customer. We should design our product, we should design our technology, we should
Sir, your voice is not coming, sir. Hello.
Hello, guys, are we connected?
Yes, sir.
Yes, sir.
So where were we lost? I guess I realized at the later moment that we have been disconnected. So can anyone may help me regarding where were we lost actually? Okay. So we were discussing about this particular thing. That what would be the checklist for technology of the product, which eventually we are going to put into the market, or and just to check how the market is going to react to this particular product or the market, and if we are going to check the survivability of new technology, whether it would be survive this throat-cutting competitive market or not. So we were discussing about this super user friendly. Whatsoever we are going to design the technology uh, or a particular product which eventually we are going to put into the market, it needs to be super user friendly. Why? Because as per the government of India, that 25% of our prospective customers are literate. We can't expect them that that they should be able to understand our GUI, whatever the requirement of our GUI is there. So we don't know how we are going to cope up with. And that particular solution being come up in terms of some of the color coding or the somewhat like this. Likewise, we do have an example of the Paytm. Before that particular episode of the Notebandi, uh, Paytm was struggling in the market. Paytm was the only one, but it was struggling in the market. But after that Notebandi event, what would happen? Each and everybody, whosoever be the rickshaw puller or your roadside vendor, they just forced to learn how to use the Paytm. And at that particular time, initially the Paytm have a number of likewise the words inscribed on their GUI, so that after understanding those words, you would come to know what it will be done if I'm going to click over there. But they made this quite easy eventually over the particular, eventually over the time, that now you have to just swipe from the left to right and put some of the credentials, likewise the number or UPI ID, and then swipe right, and that's enough. That's enough for just to make a particular financial transaction, isn't it? Even a particular beggar, means you would have heard about the news that a beggar, many of the beggars are there in India who are accepting the Paytm mode, who are accepting the whatsoever you want to donate them via Paytm or via many other third party apps. So it's all about how super user friendly we can make our product or the technology. But technology is super user friendly that only you need to worry only about to switch on and off a particular button and you are good to go. You will be connected to the internet. Any other technology? Is there any other thing you can think of that it should be, it is complicated, now I can solve it to this level also? Because ultimately, if a particular person is literate or illiterate, if you are going to ask, sir, currently switch on the button whenever you want to get connected with the internet, and switch off it just to save the electricity. So I guess that particular thing basically defines what is simply termed as the easeability. The second criteria for it, it should provide you a solution. Whatsoever the technology we are going to talk about, whatsoever the product we are thinking about, it should provide certain solution. And if the solution is basically pertaining to the larger section of the society, then definitely your technology or your product is going to be a super one, super handy to the market. The market is going to embrace it. Have you heard about, there is a startup from the Kerala, that is a startup for the, started by the four parents, two of them are the engineers and two of them are the dopouts. That particular name is the Bandicoot. What they are actually doing, they are actually designing the robots to unclog our sewage problems. Have you heard about it? I guess recently the Ghaziabad Nagar Nigam also purchased a single robot from them. I don't know whether you have heard about it or not, but if you initially what they were doing, they just designed the robot just to get into our sewage systems and just to maintain our sewage systems without any kind of the human interventions. Initially, what was that? a particular person who is illiterate or whatsoever their education background needs to be get into our CV system by means of the manual intervention. They need to unclog it. I guess Raipur do also have a few robots. So what was the particular things we were missing at that particular time? We need to get our human resources into our sewage systems where the decaying and the decomposing materials usually exhibits a number of hazardous gases. Likewise, the methane is there, the carbon monoxide is there, and which usually affects badly the health of that particular person. And eventually, most of the times we usually lost our human resources just because of the exposing with these hazardous gases. So there was a problem. And how much population we do have in our urban settlements? Around 58% of our current population resides in urban settlements. So we do have the prospective customers also there. The 58% of the population we need to maintain. So we need to be on our toes to maintain our sewage system. And how much people we need to recruit them? How much people we need to recruit to maintain all these systems? A number. And on yearly basis, we usually lose about 3,000 or 4,000 person in this particular process. So on our other side, we are saving our population. On the other side, we are giving you an effective maintenance. So that particular thing being offered by these particular robots, which is basically specifically designed only for this purpose. And the company name is the Bandicoot. If you do have some time, kindly Google it out and you would get much more insight about it, what actually they are. So it was a problem with the society, especially in the southern India. There was a problem called as a manual scavenging. So they have designed a robot just to eradicate the manual scavenging at the very first instant. Once it became handy, once it became popular, they just thought about why we are focusing only on this particular problem, which is quite a low in scale. Let's focus on something bigger. So they just turned up from their manual scavenging idea to maintaining the sewage system. The sewage system is something like this, which is basically pertaining to all. And after this Swachh Bharat mission, it is pertaining to every household, isn't it? The third one, whatsoever the technology or whatsoever the product we are going to put into the market, it needs not to be topographically limited, but it should be ubiquitous. Why it should be ubiquitous? Because if I'm going to design something which is only working at the highlands of the Himalayas, but it is not going to work in the rest of the India. How much population I can cover? How much prospective customers I can get? Maybe a few thousand, few lakhs only. Maybe a portion of our total population. And if I'm going to design a certain type of the technology or the certain type of the product which is only applicable at the coastal India, then we are bound to lose the much population which is residing in the plains of India, isn't it? Which is residing in the Thar Desert, which is residing at the highlands of the Himalayas. So similarly, whatsoever the product or the technology we are going to design, it should work in the same effective fashion. Likewise, it is working at the Andaman Nicobar, it is working at the Leh Ladakh, it is working at the Mizoram or the Arunachal Pradesh, and it is working in the Thar Desert. Correct. Likewise, if you are going to take an example of Paytm, though Paytm is basically topographically limited for the India and in the sub-Indian content. Whereas if we are going to talk about the Uber or the Ola, have you heard about that the Uber and the Ola is also working somewhere in the Europe? Guys, are we connected? Hello? Hello?
Yeah, we are connected. Sir.
Okay, am I audible now? So someone, Mr. Amit Kumar Devan, just put a message that there is no voice.
Okay, sir, that is for the long time back when it is not.
Okay. No issue. Kindly give me some acknowledgements in between so that we would be able to acknowledge it that we are still connected. We are on the same platform and still we are good to go.
Yeah,
okay.
Definitely.
Thank you. So if we are going to talk about the Ola or the Uber, The all over you in all over you have to get yourself registered for the once, whether you are in India, whether you are in the USA, whether you are in the UK or the Canada, and still whenever you are going to visit these particular countries, you can think of, okay, I have already registered it, I need to change only my location, then I'm good to go. I need not to register myself again. I need not to download any other particular app. I need not to do anything else. But what I need to do, I need to open up my location and then I'm good to go. So it is not topographically limited. Likewise, for the Paytm, if you are using the Paytm and if you are visiting the UK, then definitely the Paytm is not the registered one over there. So you wouldn't be able to use the Paytm. But if you are visiting Nepal, we are having the Paytm operations running over there. We are having the Paytm operations running at Bhutan too. So if you are visiting these particular countries, you can use it. By the same kind of the registrations, you can use it. Means there are some of the legalities which can make a product or the technology topographically limited. But eventually at the production time, it shouldn't be topographically limited. Likewise, if we are going to produce, or if we are going to have a technology for the new missiles or for the new tanks, then all these particular tanks or the missiles should be work in the same way in the Thar Desert. Likewise, it is going to work at the highlands of the Himalayas. Similarly, it has to work in the same fashion at the Arunachal. It has to be work in the same fashion. Likewise, being posted at the Andaman Nicobar. And foremost, last but not the least, it has to be cost. Whatever we are there, whatever the product we are going to lose in put into the market, whatsoever technology we are actually designing, that needs to be super user friendly, as well as that particular needs to be super cost effective and affordable. Because after this pandemic instant, earlier we were having around the 28% of our total population residing under the BPL category. Now it is being raised up to 34%. And what is basically the criteria to judge a person whether the person is basically the BPL or not? It is around 1,000, less than 1,000, 32 rupees. If a person is residing in the urban settlement, it is 32 rupees per day. Whereas for a person residing in a rural settlement, it is 28 rupees per day. If a person is not able to make 28 rupees or the 32 rupees respectively, then that particular person is supposed to be the BPL category. And if a person is not able to make 1,000 rupees per month, how we are going to charge that particular person for using our product or using our technology? Will that particular person be able even to give us 50 rupees? It's quite hard. So these are basically the 4 yardsticks on the basis of which we are going to evaluate each and every technology and its competitors, so that we would come to know that why these particular things are going on and how these particular thing is basically revolutionize our communication world, why it is still there in the developed countries, though this particular technology basically pertaining to the developing countries, but is still working in the developed countries. And if you are going to visit basically the countryside in the US, UK, or any of the developed countries, you would find that plenty of the communication channels or the plenty of the internet services are working on this particular technology only. So this is one of our typical telecom network architecture. We do have the access part, where the access part is basically the part of a communication network which lets the customer be connected with us. Likewise, for the mobile phone companies, it is basically the BTS which generates the EM waves, and by these EM waves, it let the customer be latched with itself. Once it is latched with a particular BTS, now it is the responsibility of the BTS to cater the services to the prospective customers, isn't it? Whereas whenever we are going to get the whenever we are going to get the request from the customers, that particular request is going to be marked by this access part. They are going to provide us a muxing, and after getting a muxing, it is going to forward the data to our core network. The core network is basically a part of our telecommunication network where we do have the higher computational devices, which basically able to perform certain decisions. Likewise, if you are a new customer to any of the ISP, what actually you are looking for? You are looking for a service, and what actually the ISP is looking for, ISP is going to ask you. So, what is your name? This is my form. Kindly fill it online or offline as per your own convenience. And once we are going to get your information, that is simply termed as the KYC, then we are going to give you the services. And after submitting your KYC and enabling your services, there is some time delay. Whenever you are going to apply, whenever you are going to apply a request to the service provider, okay, I have provided you a KYC. Currently, do let me use the services. What they are going to do? They are going to fetch all your details. They are going to fetch all your requests directly to our directly to the core network. And the core network, we do have the higher computational devices. That particular computational devices is going to check whether you are a legitimate customer or not, how much data you do have in, or which particular plan you have subscribed, how much data is there as per your plan, how much call balance is as per your plan, how much you have already been used, and is there any other barring condition on your account or not in the view of the low payment or in the view of the balance payment. So all these decisions need to be checked, need to be taken before any ISP is going to provide you the services. And all these decisions require certain type of the logical operations. Likewise, you have already heard about there is an operation called the AAA function, the authentication, authorization, and the accounting. So whenever we are going to authenticate you by using by means of your credentials, you have supplied your credentials to me. Okay, these are my credentials. I want to use this particular services. So what would I do? I'm going to get your credentials by me from your request. I'm going to ask my systems. I'm going to ask my database. Okay, if you do have any copy of these particular credentials, kindly supply that particular copy. So I do have the two copies. One is supplied by the customers. One is supplied by my database as per the KYC done at the initial stage. So what I'm going to do, I'm perform a bitwise AND operation. And what is the property of the AND gate? Once we do have the same kind of inputs, we are going to get the output with the same one. If both the inputs are the 1 1, then the output would be 1. If both the inputs are the 0 0, the output would be 0, isn't it? So when both these username, whenever both these copies of the credentials are quite identical to each other, that time the AND gate will come to know, okay, these two are identical to each other. So it will let us know, it will let the customer know, okay, you are a legitimate customer, you've been authorized, I am going to give you an IP and kindly use your services. So this is all the work done by means of this core network. Okay, it would be somewhat like this. So we do have the number of the different customers, or the different customers being catered by the different devices as per their services. Likewise, we do have enterprises, and that particular enterprises is basically connected with an aggregator switches. Similarly, we do have the home user, and that particular user is basically connected for the internet services by means of the optical fiber or by means of the copper wire. It totally depends. After it, once these users have generated their request, that particular request is going to be aggregated or going to be muxed. Why muxed? Because if we are going to provide a dedicated channel for each and every customer, first of all, the services won't be cost effective. Why? Because we have to maintain the dedicated links altogether. And if we are going to maintain a dedicated links altogether for all the time, then definitely it would involve certain financial resources. And we have to get back those financial resources. That's why my services is not going to be cost effective. But it can be done on the basis of the request or on the basis of the services seeked by the customer. Similarly, after getting all these particular requests, it is going to be fed to the aggregator switches. So what the aggregator switches is going to do, they are going to get the multiple muxing in a hierarchical order. And it is being, all these requests been collected and supplied to this core layer. Over here, the core layer is going to be perform certain operations. On the basis of these operations, if you are found to be an okay customer, your data is going to be put into the internet cloud. The second thing which I would like to emphasize over here, how many of you have checked your internet connection speed? On any fine day, on any sunny day, how many of you have checked?
I used to check, sir.
Sorry.
I will check, sir. The
Okay, you will
Tesla
check.
some
Okay,
site is
how
there,
many
na
of you
speed test
do
online.
know about the Okla? Whenever
Yes,
there is
sir.
a video, whenever there is a TV commercial pertaining to the Airtel comes into the TV, they usually
Sir, I used to check from that particular site only, Okhla site only. Hello, sir. Your voice is breaking, sir. Sir, your voice is breaking.
sorry about this discussion about this disconnection, but I don't know what would be the reason for it. The network seems okay, all the things are seems okay, but I don't know why this particular session is being disconnected for so frequently. Am I audible, guys?
Yes, sir. Right now you
Okay,
are
so
audible, but thing is like sometime it will be like a because of the low connectivity or I don't know. Your voice is like a very slow. It will come and it will stuck
that's
something
what
like that.
that's what I said. That each and every time whenever you complain that my voice is not uh, proper, that time we've been disconnected. This particular Zoom session been disconnected, and I have to join it again. So this kind of the problem is going on, and I would like to convey my apologies for this. I don't know whether it is from the point of view of the network, because I on a other PC I have already put all the parameters of my network in real time check, and when I just checked it out as of now, it is working fine. So I don't know where exactly the problem is. So are we good to go further?
Yes. No issues, sir. You can continue.
So what were we discussing that time? We
Sir,
were
you are
discussing about,
asking about that Okhla side. Anyone has checking that Okhla side or not?
yep,
So
yep, yep,
just
correct,
I am
correct,
replying
correct.
for that only.
Yep,
I used
correct.
to go for that Okhla side. Just
Okay.
sometime I will.
So what the Okla usually do? Whenever you are going to subscribe for any of the mobile connection or any of the wired connection, what they usually tell you, sir, we are going to provide you 100 Mbps, we are going to provide you 50 Mbps, or we are going to provide you furthermore, isn't it? But exactly from where to where they are going to provide you this particular bandwidth. Likewise, you have generated a particular request for likewise the google.com. So you have generated that particular request, and that particular request is being catered by all these devices, is being checked at the core network, and then the core network is pump your request into the internet cloud so that it would be able to reach to its destination. and way back it is going to route your acknowledgement back to you, that whether you have been reached to the google.com, so you would get a Google page. If you are not connected with the internet, you are going to get that particular page, okay, this particular site is not reachable, isn't it? But ultimately an acknowledgement is ought to be there. So whenever we are talking about the 100 Mbps connectivity, the 10 Mbps connectivity, the 20 Mbps connectivity, it never pertaining to the download speed from the internet. It always pertaining from the here to here. At the moment, our network, whatsoever the network we are working, whether it would be the BSNL, whether it would be the VI, whether it would be the Airtel, or whether it would be anyone. So from here to here, at the periphery of the internet cloud, we are going to give you whatsoever we are going to promise you as per our SLA or the service level agreement. Whatsoever the type of the plans you can think of, in technical, these are nothing but the SLAs, the service level agreement, that we are going to provide you our services. That's why that particular agreement been signed between you and us. That's why you have subscribed our services. And if I have promised you that I am going to provide you the 100 Mbps speed, that time the 100 Mbps dedicated bandwidth should be from here to here, not to the internet. Means up to the reachability of the internet, I am going to assure you 100 Mbps speed, but it's not necessary that from the destination you would be able to download with a 100 Mbps speed. Okay. What the Ookla usually do? The Ookla usually charge these internet service provider a particular fee to host their server at their periphery within their network. So if you are going to be an Airtel customer and the Ookla has provided one of their hosting at their Airtel network itself, like us from here, that time if you are the Airtel customer, you need to generate a request. Now that particular request is generated by you is going to be processed by all these network elements, and after getting into the core network, as we do have your destination within our core network, your request need not to be pumped into the internet cloud, but your request would be catered within the network. So how much latency you are going to get? Earlier you were getting the latency through the internet, means much more latency. Now you are going to get the request catered from here within our network itself. So within our network we can control the latency, and if we can control the latency, ultimately it would take less time for your service acknowledgement. You are getting the acknowledgement in less time, it means you are going to get the better results, isn't it?
Yes, sir.
So this is what the Ookla usually do. As if we are going to talk about the BSNL, BSNL doesn't subscribe any services from the Ookla. We do have our own server being located at the periphery of the internet. Okay. By the end of the session, I will tell you that particular IP, and you can check out your internet connection. But for the other ISP, likewise, Airtel do have the Ookla subscription, but whereas the VI or the Idea don't have. Then, if you are being an Idea customer, you have generated a request to the Ookla server. Where the Ookla server is? Ookla server is somewhere in the internet or else at the Airtel network. So you have generated your request. That particular request is being processed, and your request is being put into the internet cloud. Now, after getting into the internet cloud, your request will travel to its destination. It will take much more time. So, what would be your experience would be rated like? You are subjected to much more time period. If you are subjected to much more time period, that time your plan or your network connectivity is supposed to be the slow one. So you are going to get that particular kind of the acknowledgement. Okay, you are subscribed for the 100 Mbps, but you are getting 25, you are getting 20, you are getting 10 Mbps connectivity. Okay, but whereas as per the try, each and every service provider need to host one of the server at their periphery, but mostly don't do that. So what do we mean by the broadband? Though as per the name suggests, the broadband is basically a very generic term. Likewise, earlier we were having a band of the frequencies. So there would be a narrow band filter, there would be a there would be a low pass filter, there would be a high pass filter, there would be a band reject filter, there would be a band accept or the band pass filter, isn't it? So the band specifically signifies the band of frequencies which we are talking about. And the broadband means earlier these particular telecommunication was only meant for the voice, not for the data. And what is the bandwidth for the voice? The bandwidth of the voice, if we are going to talk about the bandwidth of our ears, it would be from the 20 to 20 kilohertz. And if I'm going to check the bandwidth of my voice, which I'm just talking about, it would be around 3.8, 3.6 to 3.8 kilohertz. If we are going to talk it round off, it would be around 4 kilohertz. So earlier we were having only these 4 kilohertz kind of the channels. And the 4 kilohertz channels is quite narrow. That's why the earlier applications of the telecommunication usually termed as the narrow band channels. Whenever we were using the dial-ups, whenever we were using the telephone lines directly jacked into our PC, dialing a particular code, that is the #172222, and we were connected with the network with the connectivity of around 96 kbps at the max of 128 kbps. And that is usually termed as a BRI, PRI, if you have heard about it. पहले banks को एक line जाती थी ना. Earlier, all the banks were working. The main branches of your city was working on some connectivity, and that particular connectivity being carried out by the means of the BRI, PRI. If the BRI is the basic rate interface, the PRI is the primary rate interface. If we are talking about the PRI, it usually gives a data speed about 196 kbps only. So earlier, by using the same voice channels, we were using those voice channels for our data, but the data throughput is very low. That's why all the earlier services were termed it as a narrow band services. Now, as we have increased the data throughput over the same channels, we have increased our frequency, which is going to take care about our data from the one location to another, from the one node to another. And by increasing this particular frequency, now we have increased our total data throughput. How we have done it? In the subsequent slide, you are going to get a fair idea about it. Okay, sir. So
Yes,
what?
sir.
Sorry.
Okay, sir. I'm saying yes.
Okay. So what do you mean by the broadband? The broadband is basically any data connection which is having a data throughput at least 2 Mbps. The 512 is the older definition as per TRAI. The new definition of the TRAI says it has to be 2 Mbps, at least 2 Mbps, and we at the BSNL is doing it since 2016. Whenever the data throughput rate was only 512 kbps as per TRAI. So any data connection which is always on means ultimately one customer need to put either the on or off the switch, and that's it. They are good to go, or they are good to get connected with the internet. It has to be fast. It is going to provide you at least 2 Mbps connectivity, and the furthermore up to 100 Mbps. It has to be ubiquitous. This particular technology of the broadband, if this particular technology of the broadband is working at the highlands of the Himalayas, it has to work in the same fashion at the coastal India part. It has to provide the same kind of the service at the Andaman Nicobar. It needs to provide at the same kind of the service at the Thar Desert. And it's need to be super user friendly, as well as it has to be super economic. And at the BSNL, we are providing actually the 50 rupees plan, including all taxes and all, to our towards the rural India and to the places where exactly the people usually don't reside more. Likewise, have you heard about a village called the Mana village? That is in Uttarakhand. That is the last motorable village.
Yes, sir. That is
So
in
in the Mana,
Badrinath, na, sir. That Mana village you are talking about.
correct. So in that particular village, we have put a system that costs around 50 lakh rupees. And we have provided a connection to the Gram Panchayat there for the 50 rupees per month. And we have put the complete system only just to provide a service to that particular Gram Panchayat. So we don't know whether we would be able to recover that particular initial cost or not. But we are providing, and that 50 rupees you need to provide, you need to only put the electricity to our device, and you need to switch it on, and that's it. You are good to go. You will be get connected to the internet. Have you heard about there was a okay, that is a basically discussion of some other part. So why we are going to talk about the copper based broadband technology? Because we are basically the one of the colonial country of these European powers, isn't it? What is the advantage we got after being a colony? Exactly, for their own needs, all these powers which colonized us, not only us, but all the third world countries, basically all the developing countries, that they have to establish their own communication network. Once they have established this particular communication network for their own sake, but after the freedom, we got this particular communication pre-installed network as a gift. And initially there was no fiber, so the fiber was there, but it is not quite applicable because we don't have the such kind of the equipment that time. So we just had only the conductors, and one of the cost effective better conductor is the copper. So we just got the gift of this underground copper wires. So we have just scaled it up just to provide the services to any nook and corner of the country. Initially, we worked only with the copper. So we had a copper network already established within our country. We need to utilize it more effectively, because ultimately this particular copper lines is only for the voice communication, for the narrowband services. Now we need to provide you the much better, higher data speeds. So if we do have one of the things is already freely available, why to put more financial resources to establish a new network? We do have already copper network established within the field units. So if I'm going to provide you the much better services over the fiber, I need to get this fiber network be enriched. I need to get this fiber network be established within the field units from ab initio, from scratch, and that would involve much more cost. And if I'm going to put my financial resources over there, what I would expect to recover it back. So I can't keep my service viability by means of the fiber at lower prices. That's why still the fiber plans is not much cost effective. Whereas for the copper plans, we do have plans as low as possible 50 rupees. So just to utilize this pre-existing copper network, we have just purchased, or we have just developed this particular technology called as a XDSL. That DSL stands over here as the digital subscriber line. Earlier we were having the analog line over which we were sending our voice. Now we are using the same analog line or the same copper line or the same conducting line to use it as a media to transport my digital data. That's why it is simply termed as a digital subscriber line. The X stands for the different variants which are available. There are a number of the variants of this DSL which are available into the market. But rather than talking about the DSL, let's talk about this Ethernet broadband first of all. Okay, this Ethernet broadband is nothing but it is the same Cat5 or the Cat6 cable by which we usually extend a network within a very limited periphery. Likewise, you do have your labs at your own university, and in those particular labs you would find that each and every desktop or the laptop being connected by means of this fiber or by means of this cable. That would be maybe the Cat5 cable, or that would be maybe the Cat6 cable. So if these particular Cat5 or the Cat6 cable we got a particular port at our laptop or the desktop that is usually termed as the Ethernet port. You need to jack that particular cable in your Ethernet port and we are good to go. You are being connected to a network. If you do have the proper credentials, if you do have the proper IP, you would be able to get connected with the network, you would be able to use the services. But what is the disadvantage of this Ethernet broadband? First of all, this Cat5 or the Cat6 cable do have a limited applicability. The limited applicability up to 2 kilometers maximum if we are using the Cat6 cable. Means in a one go you can go up to the 2 kilometers. So if I am going to put a particular user around 6 or 7 kilometers apart, how much repeaters I need to use? After each 2 kilometer, I need to put a new repeater. I need to put a new system, which is not only would be able to regenerate my signal, but also would be able to reshape it and would be able to amplify it, so that it would be so that my input data would be able to reach up to its destination. So ultimately, my cost is going to increase manifold. Though this particular technology is quite simple, I need to only jack in my cable. That's it. But it involves a hell lot of complexity. It involves a hell lot of financial resources to get invested. That's why it is not very much famous into the field units. But for a local LAN or for the local area network, and especially for a wide area network, we can use it. But it has a very limited applicability. The second one is the cable broadband. So in the Raipur, you would have this particular flavor of the cable broadband. Earlier, before this 2016, whenever the telecommunication ministry, as well as the TRAI, make it mandatory to use the set-top boxes. Have you heard about the set-top boxes? Probably one of you do have at your household. Hello.
Yes, sir.
So what the set-top box usually do?
No much idea about set-top. Like you are asking about that set-top
Set-top box. I am
of
asking about the set-top box only,
DTH,
sir.
whatever.
Sir, I am asking about only the
Like,
set-top box.
the television, this.
Sorry?
Sir, based on that setup box, so what we have used for that, like a D2H point of view, that that will like a distribution of that particular channel. For that purpose, we are using
Correct,
something.
sir. Correct,
That much only
sir.
I know.
Correct, sir. Correct, sir. You are very much correct, sir. And what exactly by means of the DTH or the direct to home, what we usually get? We got the voice and video, isn't it, sir?
Okay.
So for the voice, we do have the FM kind of the modulations. For the video, which we do have a special kind of the modulation, which requires higher bandwidth. That is the VSB-SC. I guess you are very much familiar about it. The vestigial sideband suppressed carrier.
Yes, sir.
Isn't it, sir?
Yes, sir.
And why it is the vestigial sideband? Because if there would be a bandwidth is the BW of a single band, that time we are going to increase that bandwidth to accommodate all these video signals. So that particular coaxial kind of the cable was there way back around 1996 onwards up to 2016. Till the time this particular DOT as well as the time didn't make it mandatory to use the set-top box, just to make account how many digital subscriber we do have, which basically enjoys the TV services. So afterwards, after this STB became mandatory, earlier we were using all these kind of the cable TV from a local source, from a local vendor, and that particular network which they have set up over a period of these 20 years, that particular network becomes obsolete over within a month or so when this set-top box become mandatory. So most of us have opted for the D2S services. We have put a set-top box, we have put a VSET stations in our households, and by means of the VSETs, we've been connected directly to the internet links, and we are using these D2S services. But what about these pre-existing cable network? So these pre-existing cable network is also there. It is still been there. And why it is still been there? Because earlier then hopefully all these particular local vendors were supposed to provide us the voice and video services over these particular coaxial cable. But what is the positive with this coaxial cable? It needs maintenance. First. Second, the initial investment would be very high. Whereas it basically supports two things. It basically supports the voice. Second, it supports the video. Video which contains much more bandwidth than your voice. So if we are talking, if we are going to replace the voice signal in our conventional way by means of our digital lines, by means of our digital signals, then definitely if I am going to put the same digital signals over the higher bandwidth offered by this coaxial cable, which carries the video signal also, then definitely these cable broadband or these cable network would be able to offer me much higher data rate. Isn't it, sir? And what is the typical bandwidth available for the video? That is basically the 20 megahertz channel. So up to 20 megahertz, we are having a huge bandwidth. And how much data we can accommodate in the 20 megahertz, then we are going to get a very clear picture about it. You yourself would calculate how much data would be there. But as the maintenance cost of this cable broadband as well as the penetration capability is quite low. Likewise, for after each and every single kilometer, we need to provide some of the boxes at our poles so that we would be able to regenerate and amplify or the reshape these particular signal which usually carried out by this cable broadband. What about this broadband over the power lines? Over there, the resources are quite financial intensive. Over here, the resources are quite financial intensive. But what about the power line? The power line is nothing but the same line by which we usually get the electricity. And what is the advantage with this power line? These power lines do have the access to every household in the country. Means about 99% as per the government of India. That 99% of our population is covered, do have the electricity connection. So if one person do have the electricity connection, then definitely that particular person is connected to my network. And if I'm going to use the network of these power lines to provide my broadband services or provide my internet services, will it cost me anything to establish a new network into the field units? No, definitely I'm going to save my financial resources. And I'm going to sign an agreement with all these power distribution companies that I'm going to provide, I'm going to put my I'm going to put my signals into your lines, and that particular signal is going to be travel up to this particular distance to this user. And that particular user, at the user side, I'm going to segregate the electricity from the internet, and I'm going to provide the customer an internet connection. So isn't it a win-win situation? Means I need not to put my resources, financial resources, to establish altogether a new distribution network for my internet services. Similarly, these particular power distribution companies already had their distribution network, and that particular distribution network have access to each and every household. So isn't it a win-win situation for me as well as for these power distribution companies? Then why still it is not quite popular? First of all, the reason behind it, the power line do have the infinite power behind it. Though we usually step down it, we usually step up it, we usually manipulate the power, but the actual power quantity we do have back in the power lines is the infinite. So if anything, any silly thing happens due to which our customer is going to expose to this infinite power, it would be hazardous. Second, the first reason is this one. The second one is the have you witnessed the power lines? Sir, बिजली के खंभे तो देखे होंगे ना?
जी sir.
So what is there? Which kind of the conductors we usually use at the power lines? It is basically some alloy of aluminium, isn't it? Why aluminium? Because it is going to be If it is not going to be the heavy one, then the elongation and as well as the maintenance of the power line becomes very easy. First. Second, if we are using not the pure aluminum, but if we are using the aluminum alloy with the impurities, then definitely what is going to be changed? Its conductivity is going to be changed. If the conductivity is going to change, the resistivity is going to be changed. If the resistivity is going to change, then what would happen? If the resistance is high, the power losses are high. First. Second, it is not going to exhibit the same kind of the behavior throughout its length. Just because of we can't ensure that this particular cable is having the same kind of the impedance or the same kind of the resistance throughout the cable. If we are going to talk about the infinite length transmission line, that particular transmission line of the infinite length usually do have a constant resistance throughout its length, isn't it, sir? That is a 320 by root XL, by root X and by root LC, sorry, by root LC. 355 ohm by root LC. That is what, if I can remember correctly, that is what the impedance measured, or that what the impedance offered by an infinite length transmission line. But over here, if we are going to talk it, if we are going to consider this power line as a transmission line, then what would happen? For the infinite length, it won't exhibit the same resistance. The resistance is going to be changed. If the resistance is going to be changed, ultimately which kind of the signal we have put into the power lines? We have in the power lines, we have put an analog power signal, and that having a frequency of 50 hertz. So ultimately, along with the resistance, there would be an inductive impedance too. And we are supposed to put the more frequency power. We are supposed to put the higher frequency signal into the same power line. So ultimately, my resistance would be, if we are going to talk about that all these are the ideal lines, my resistance is going to be same. Then my impedance is going to be increased, because my impedance is going to be the inductive impedance. R plus J omega L is the there, isn't it? If my inductive impedance is going to be increased, my power signal is going to deteriorate more. There would be much more power losses for the power companies as well as for me. So ultimately, if there is a much more power losses, rather than getting whatsoever they are getting as a rental from me or as a rental from any of the ISP, they are losing much more power just because of the increase of this impedance of our cable. As we have put a new higher bandwidth signal, as I have put a new higher frequency signal into the power line. So the more power losses would be there. So they are not supposed to get the much more from my side as a rental, but they are going to lose more. But as per the BSNL, we are providing these particular services in Kerala. As of now, we have tested it only in the Kerala. So we have just discussed about the newcomers as well as the competitors into the market. It is one of the real competitor of this XDSL. It is already been there in the USA. It is already one of the technique by which we are providing you the internet service in the Canada and as well as in the US. But it is not very much famous in Indian supported. The last one is the XDSL. So these are basically the reason that we have only come up with this DSL or the XDSL, that okay, we have this particular technology at our disposal. Now we have to make maximum out of it. Just a second. Okay, how many of you do have the subscription to the Netflix, Amazon Prime, or somewhat like any OTT services?
So that is the I have a connection with the Geo fiber. With that, it is came 14th OTT that I have, but
Okay,
not
okay.
Netflix.
Okay, sir. No
Amazon
issue.
Prime.
Why I just asked this particular question, because I just need to explore the tendency whenever being a general customer, which kind of the tendency we do have while using the internet? We do have the tendency to visit these OTT. We do have the tendency to perform certain transactions online. We do have the tendency to perform certain transactions like in terms of the shopping or means whatsoever is out our way of living. We usually do that particular thing, and how much data we are going to generate. Likewise, if you want to get connected with this OTT platform, you need to open up their app and you are going to search the content in which you are interested in, and then afterwards you are going to put, there would be a symbol which basically signifies play the content, and you are going to put a hit on that particular symbol, and then that particular content is going to be automatically played. So you have generated some request. You have generated a request to open up the application, then the application get opened up. You have generated a request to search your content, and as an acknowledgement, you get all the probable suggestions. And then you have put a request to play it, that particular content is going to be played. Now, after that particular content is playing, you need to do anything? I guess not. You have to just chill out, you have to watch your content, you have to enjoy your content. That's it. But you have generated a request maybe around the 20 KB, maybe around the 1 MB. Let it be the 2 MB data you have generated as a request to play the content. But in a response of this 20 MB data, the 20 KB data, or the 20K data, how much data we are receiving from the server? Maybe a few gigs of the data we are receiving, maybe 1.5 GB of the total content we have played, or maybe the 20 MB data we have played, or maybe a 500 GB data we have played. It totally depends, means which particular content we are interested in. But we are generating less, and we have a tendency to download more. That is basically one of the tendency being carried out by the general customers. If we are not a very research oriented person, if we are not the scientist, if we are not the park where exactly we do have the 10G connections only for the uploading of their research papers, means their research work which they needs to upload somewhere, so that we can perform a collaborative research. So a general customer have a tendency to download more and upload less. So if we are going to have a complete bandwidth, if we are going to have a limited bandwidth, how you are going to segregate this particular bandwidth? Whether you are going to say, okay, half of the bandwidth for the upload, half of the bandwidth for the download. That is also one of the segregation, or that is also one kind of the division. Another kind of the division, I would like to give download more bandwidth, whereas I would like to give less bandwidth to the upload channels, so that whatsoever I have a tendency to upload less, okay, that would be accommodated by a less bandwidth. I have a tendency to download more, that time total download would be, I would be able to get the much more better experience with a higher bandwidth at the download side. So these two kind of the segregation of my channels would be there. And why I have categorically mentioned this particular thing, because the DSL do have the two kind of the segregation. One is called as a symmetric DSL. Other one is called as a asymmetric DSL. Over here, you just find out a particular word, the ADSL. That is simply from the asymmetric DSL. In the asymmetric DSL, we do have the division of our available bandwidth asymmetrically. We have given much more bandwidth to the download channels. We have given a less bandwidth to the upload channels, whereas we do have a limited bandwidth. Okay. So it is one of the speed comparison about the different broadband technologies. So initially we just started with this voice band modem, where we actually offered you the narrowband services about 128 kbps to 198 kbps. Then we just had with the ISDN services, or it is usually termed as the hotline services. Then after this ISDN, the BRIs, PRIs, as well as the ISDN, we just come up with the ADSL. So it is basically the XDSL. Initially we were having the SDSL. Then we just come up with this particular novel. Okay, the people do have the tendency to download more. Now, divide the available bandwidth unequally between the upload as well as the download channels. So just we come up with this particular solution, the ADSL. Then we were having the hybrid fiber or hybrid fiber and the copper technology or the VDSL technology. So the VDSL is the available technology which is being still in use throughout the world and out of the world. If in the especially in the developed countries, if we are having 100 internet connections out of 100 internet connections, the 64 internet connections are basically dominated by this VDSL technology. The rest 32 may be over the fiber or some other technology, but the around 64%, sorry, 74, yeah, around 74% of the total internet connections, the 74% would be pertaining to VDSL, especially for the developed countries. Why it is there? We are going to have a discussion about it. Then we are having the pure fiber. So it is again, what do you mean by the XDSL government? It has to be always on. It has to be the fast as possible. It should contain the voice and the data simultaneously. And it would be supplemented and it would supplement a number of the value-added services. Then this is our XDSL family today. We are having the semantic DSL as well as we are having the semantic DSL. In the semantic DSL, we have a tendency to have the identical upstream as well as the downstream data rates. Why? Because we have given the similar bandwidth, or we have given an equal bandwidth to both these channels. As for the asymmetric DSL, we have divided the channels unequally. That's why we have a tendency to have the higher download rates rather than higher upload rates. And there are the 4 main variants or 4 main flavors which is available in terms of the XDSL. That is the one of the called as the ADSL, the asymmetric digital subscriber line. Another one is the HDSL or the hybrid data rate digital subscriber line. Then we are having a VDSL, the very high data rate digital subscriber line. It can provide you data throughput up to 100 Mbps up to a distance of 1 kilometer. The other one is the IDSL or the ISDN digital subscriber line. So I'm going to stop here for only 2 minutes as I need to fetch a glass of water. So is that okay with you?
Yes, sir. Yes, sir.
Okay, sir. Yes.
Just a second. So are we good to go?
Yes, sir.
Okay. So we just had this particular discussion. Now we are providing you the outline services to one of the some political dignitaries over this same DSL version, and the DSL version is simply termed as the IDSL. Okay, so it is one of the system reference model for this DSL technology been provided by ITU. So over here, the T stands for the terminal equipment. That is your computing device over which you are supposed to get your internet connections. Likewise, you are using a mobile phone, that is also a T. You are using a desktop laptop, that is also a T. But at your location, we have installed a NT or the network terminal. And that particular network terminal do have one physical layer. So physical layer means a physical port over which you can jack in your Cat5, Cat6 cable. Maybe the another physical layer would be your air interface, by which we are going to provide you the Wi-Fi services. It is usually termed as the ATUR, the asynchronous transfer unit receiver. Okay, or the asynchronous transfer unit remote. Remote means at the remote side. Over here, that is basically the terminal to system interface, that is the terminal to remote interface, and that is the user remote interface. All these are basically some of the bookish things which eventually you are going to go through whenever you are going to go through few of the articles as well as few of the research papers. You would find such kind of the interfaces we are talked about. What exactly we are going to talk about at the UR, what exactly we are going to talk about the UC. What actually over there, whenever we do have any kind of the computing device, that particular computing device pertaining to certain standards, and that particular standard in case of the computer network is the OSI model. Whatsoever we are going to generate, whatsoever the type of the data we are going to generate, whatsoever the type of the data we are going to receive, it needs to adhere to a standard. And that particular standard is our OSI layer, isn't it, sir? You would have already went through the OSI, if I am not wrong, sir. The OSI basically stands for the Open System Interconnections. So if you do know about the OSI, I need not to get deep into the OSI. So I'm just so whenever all these particular systems, the T is basically the computing device which is working over the OSI layer. But over here, if we are talking about the same telephone line, the same copper conducting wires available, how much conducting wires we do have over there? A single pair. Over there, we can't have. But what is the technicality over here? What is the technicality which is going to be provided over there? That each and every of these devices are basically utilizing the OSI layer. So they are going to generate the data in terms of the Ethernet. That's why we usually do have the Ethernet port at our laptop or that desktop. So once they are generating that particular data at the Ethernet port, how much ports would be there in the Ethernet? There would be the 4 pair of conductors, whereas over there we do have the single pair of conductors. Second, we just need a kind of the conversion from the data which we are receiving from the 4 pair of conductors to the single pair of conductors. First, that is our requirement. The second one, whenever all these are generating the data, and if this particular telephone lines is quite thin in nature, maybe around the 4 mm dia or maybe around less than 4 mm dia, that time how much power we can think of? Is it can stands for the 220 volt, or maybe around 30 watt of the data, or more than 30 watt of the data, or the 20 watts of the data. It can only handle up to the 1 or the 2 watts of the data. That only the 1 or 2 watts of the power, not about the data. That time we can't exhibit the much higher power on these links, as these links are going to be get distorted. Similarly, once these TEs are working over some OSI layer and these are generating you the data in the Ethernet frame format, then definitely over here, what exactly we are doing? Over here, we are having a parallel data communication. But at this instant, we are having a single user interface. That is why means of a single pair of conducting wires. So all the data needs to be converted into the serial mode. Over there, we do have the parallel data. Over there, we are having the serial data. Serial data keeping the power as low as possible. So how to do that? So there would be a conversion. There would be a conversion from the Ethernet packet to the ATM cells. So that asynchronously, we would be able to send the data in serial mode. Sir, are we good to go?
Yes, sir.
Or is there anything you would like to ask, sir? So over this UR as well as you see the user remote interface and the user central interface. This is basically the interface over which we are going to send only the ATM cells, the equivalent of ATM cells. Whereas in the TS or the terminal as well as the system interface, we are going to send you the Ethernet packets. And there would be a conversion between the TS to TR. This would be the conversion of our Ethernet packets into its equivalent ATM cells. So what exactly we are having? The Ethernet to ATM, then we are going to send the ATM, then we are going to transport the ATM back into the Ethernet packet. Why into the Ethernet packet? Why we are not processing the ATM cells? Because Ethernet packet is the simplest, most frame format which is to be understood by our computing devices. It is having one of the frame header, then we are having the source IP, we are having the destination IP, we are having the traffic engineering bits, then we have the 1500 bytes of the data at the max, from the 64 bytes to the 1500 bytes, and then we are having the CRC or the security bits. So the network layer understand this particular simplest frame format easily, so it will take much less time to get processed. That's why there is a need. But over here, because of the certain limitations, we can't exhibit much more power. So we have converted the complete frame, complete Ethernet frame into a 53 bytes of the equivalent bit, 53 bytes of the equivalent ATM cells. And now we are going to send these ATM cells so that this particular user interface won't be exhibit to a higher power input, as well as it is going to send for the asynchronous communication. So for just to cater these two particular purpose, we need to change the Ethernet into the ATM and the ATM back into the Ethernet. Over here, the UC is the basically user center. VC is basically the central office B terminal. And over here, the V is basically your network interface. So over there is no need of having any kind of the conversion. So the Ethernet packet is going to be processed by means of the broadband network. So it is one of the standard over there. So these are basically the access network wireline data transmission standards. We are having these different standards, and each standard do have its own applicability as well as the equivalent data rate. Likewise, over there we do have the VDSL2 as well as the VDSL vectoring. These are providing your data rate up to 100 Mbps. And what would be the standardization for this? That is ITU-T G993.5. And what would be the means, it is what the evolution we are having. We are now working over here, and it is basically in the market way back from the 2006, and now it is what we are developing, the GFAST technology. So how many parameters we should take care whenever we are going to provide you an internet connection or the XDSL? There are the two main parameters. If we are going to talk about the conductor, then definitely the power loss would be one of the factor. Then we are having the attenuation. The second one is the capability of our signal generator. How much better signal we would be able to generate. Okay, let's talk about this SNR. As we know, nothing can work over the absolute temperature, isn't it, sir? At the minus 273 degrees centigrade, nothing is going to work. Why? Because at that particular time, the motion of the electrons usually cease to happen. But as soon as we are going to increase the temperature from the minus 273 to let it be minus 15 degrees centigrade or some other, then what would happen? This particular temperature or the energy which we have supplied to increase the temperature is going to be supplied to these electrons, so that the electrons is going to start spinning or going to start movement. And as we are going to increase it, the motion of the electrons or the spinning of the electrons or the vibration of the electrons is supposed to be increased. Then what would happen? Let it be, we are here, we want this particular electron to be transferred to this location in no time. Then if this electron wants to get transferred from here to here after getting sufficient energy, what would be the path it can follow? It can follow either this particular, the straight path, the shortest path. That is what we are basically interested in, because if it would be the shortest path, it would cost me least power dissipation, least power loss. But as such, if we are going to increase the temperature, we are going to increase the entropy level. And what is the entropy level? We have already studied in chemistry that they are the two levels which we usually talk about in terms of the thermodynamics. One is called as the entropy, other one is called as the enthalpy. So entropy basically signifies the degree of randomness, isn't it? So over there, if we are going to increase the temperature, the degree of randomness for the motion of the electrons is going to increase. So we don't know if we have instructed the electron to travel from here to here, then the straight line would be our desired path. But we don't know whether our electron is going to transfer in this particular fashion. If we have supplied much more power, then it may travel up to the destination, maybe like in a zigzag motion, likewise this one. Though still the effective commutation from here to here, but the total path followed is quite higher in length. And if it is going to follow a longer path, then a much higher power is going to be lost. If we are losing much more power, then exactly the power can't be created, can't be destroyed, but it can be converted from the one form to another form, isn't it? That is the law of power conservation. So as per the law of the power conservation, we have lost the meaningful power, and that particular lost in the meaningful power get converted into the unmeaningful power, and that particular unmeaningful power or the power lost is usually termed as a noise. So after increasing the temperature, we are increasing the noise. If the temperature is there, the noise ought to be there because of this entropy. And this particular kind of the noise is usually termed as the AWGN, the additive wide Gaussian noise. So I guess you are very well versed about this AWGN, the additive wide Gaussian noise, as it is directly proportional to our temperature coefficient, isn't it? So are we connected?
Yes, sir. Yes, sir. You are connected.
Okay. So the AWGN wide Gaussian noises ought to be there if our signal generator is working, because it is going to be work over certain temperature. So the SNR basically signifies the capability of our signal generator to generate a meaningful signal better than our noise whatsoever is available at that particular time. So as much superior signal we are going to generate in comparison to the AWGN noise, that time our SNR is going to be higher. And also the SNR is also depends on some other attributes. Likewise, there shouldn't be any kind of the joint, or there shouldn't be any kind of the joint in our line, because if the joint is there, then definitely the resistance is going to be changed. If the resistance is going to be changed, effectively our entropy is going to be changed. We would have the higher tendency to lose more power. Similarly, if we are going to talk about the attenuation, we are working over the broadband frequencies. If we are using the broadband frequencies, means any frequency higher than 4 kilowatts is supposed to be working in a broadband. So it is effectively, in a bookish language, it would be much more than 20 kilowatts, because that's what the frequency band we do have from the 20 to 20 kilowatts. That's what we can speak and we can hear. So this is what the total narrow band frequency, and higher than 20 kilowatts, it would be accounted as a broadband frequency. So whenever we are going to whenever we are going to generate a signal having the higher frequencies, then ultimately we are going to increase the inductive impedance. Though the resistivity is there, because we do have a copper, where that is basically one of the conductor. So the conductor do possess certain conductivity and it do possess certain resistivity. It is not going to change much frequently. But as such, my frequency is higher, then my inductive impedance is going to be increased. As such, my inductive impedance is going to be increased, my effective resistance or my effective impedance is going to be increased. And if my effective impedance is going to be increased that much, we are going to lose more power. So we are contributing much more into the noise signal. Okay. So other than the AWGN, we do have a certain other kind of the noises too. So the attenuation should be at least as possible, whereas the SNR means the capability of a signal generator to generate a better signal in comparison must be as higher as possible. Kindly take away from this slide, that is only these two particular points. So there would be this representation. If we want to send a signal up to 2 Mbps speed, and if I am going to use the 0.5 mm of my dia, or the wire size is my 0.5 mm, that time I would be able to send the same amount of power up to a distance of 5.5 kilometers. And that is quite very much needed in terms of the developing countries, because in India we do have such kind of the habitat structure, that especially in terms of the rural India, people do prefer to reside nearby their fields. So if you do have a field located over there, maybe the next household you would encounter maybe around 2 kilometers apart, 3 kilometers apart, 5 kilometers apart. There are a few villages in Arunachal Pradesh which is basically having only the 1 or the 2 persons living in the villages, and the villages are basically 7 to 8 kilometers apart, or more than that. So if in that particular condition, if I would like to provide the services to all these customers, then which kind of the technology I should go for, which provides me a data capability to penetrate much more distance over the same amount of the power. So it would be one of the thing that up to 5.5 kilometer I would be able to provide you the 2 Mbps connectivity. So I am providing you a broadband connection. Whereas if I'm going to lower down my wire size, if I'm going to get much less thinner wire, that time this particular penetration capability get exhausted. Because if the wire is thinner, the resistivity is going to increase. I guess resistance equals to rho L by A. So the area is going to be get less. So ultimately my resistivity is going to get increased. Similarly, if I'm going to increase my data throughput rate over the same kind of the conductor, then still I'm going to lose my distance. I'm going to lose my penetration capability. And why it is so? Because I have increased my data rate. If I am increasing my data rate, I am increasing the bandwidth. If I am increasing the bandwidth, what exactly I am increasing? I am increasing the amount of power which I am going to put. I am increasing the frequency. If I am increasing the frequency, my impedances are going to increase. So the loss of the power would be much more rapid. than what I thought. That's why this particular distance, which is supposed to be 5.5 kilometers, is going to be reduced up to 3.7 kilometers, or it would be likewise half. So these are basically the two structures, the XDSL coverage versus data rate. The highest coverage would be available only for the ADSL, or up to a distance of 5 kilometers. Whereas for the VDSL, we are having the highest data throughput within 1 kilometer. And that is one of the positives with the VDSL. VDSL never provides us the capability to penetrate much more distance. Whereas it has the capability to provide us the much more higher data rates in a very limited fashion. Okay. As of now, you are in Chhattisgarh, maybe preferably at the Raipur. So, do you have any township coming up or mushrooming up in the Raipur or in the new Raipur? Hello, guys, are we connected? Hello. Hello. Hello.
Yes, sir. Yes, sir.
Okay, so is there any township or the skyscrapers or the buildings have been erected nearby Raipur? Means where we do other flats as well as many other things? Likewise, if we are going to visit the Mumbai, if you are going to visit the Pune, if you are going to visit the Delhi, you would find plenty of the buildings being mushroomed out. We are having around the 20 floors building, we are having around the 50 floors, maybe the 90 floor building is there in full construction in full swing at the Navi Mumbai side. So what exactly we are talking about? We are exactly talking about the 100 floor building. And what would be the approximately height of your room? Means the room in which we are residing, in which we usually spend our life, our bedroom or our drawing room. So what would be the probable height? What would be the height of your room? From the tile to ceiling, what would be the height, sir? It would be around 12 feet. It would be around, if we are going to take care all the lantern and all, it would be around the 15 feet. Isn't it, sir? So for a single floor, the approximately height of a single floor is the 15 feet. And if we are going to talk about the 50 floor building, what would be the height of that particular building? The 15 into 50, that is around 750 feet. Isn't it, sir? And this particular VDSL can provide us 100 Mbps connectivity. As per this, at least 50, 30, 40, it can provide us significant speed up to a distance of 1 kilometer. So the 1 kilometer means how many feet would be there? 1 kilometer means 3,000 feet. So the 3,000 feet, it can provide you a data throughput around 50 or more than 50 Mbps. And this 50 floor building having how much height? Around 750 feet. And in those 750 feet in a nearby region, how many families we can think of? Maybe the 1,000 or more than 1,000. Isn't it? So these 1,000 prospective customers we are getting within the periphery of 750 feet or maybe 1,000 feet if we are going to take care about other things. So within 1,000 feet, we are going to get 1,000 families which is residing there. The similar kind of the fashion we do have in the European countries, maybe in the USA, in the Canada, as well as in the European countries, especially where we do have the tendency to get the hamlet type of structure where all the families are living together in a very nearby or in a proximity. So that what exactly we usually do? We usually do a fiber copper. We usually do a fiber copper technology implementation. We are going to fed this VDSL node by means of the fiber connectivity, and over the VDSL is going to provide each and every household a copper connectivity which is going to provide us a data throughput about 100 Mbps. That's why this VDSL is very much famous that all of a sudden about 64% of the total data connections basically basically given by means of this VDSL technology throughout the world. You would get a report about this particular kind of the applications at the ITU side. Now we are having the attenuation versus the lineage. So who is very less affected by the attenuation? That is the ADSL, and who is much more affected by the attenuation? That is the ADSL as well as the VDSL. Okay, so it is what we were talking about. The VDSL is very much famous, but what is the possibility that it is not applicable to the rural India? It is just applicable to the urban India or to the urban centric settlements, where we are having a number of the families or the number of the prospective customers residing in proximity, and we can provide them the connections. Okay, that's why this VDSL is very much famous. So how does the ADSL work? Initially, we were having only this particular band. This particular band is nothing but a voice signal. So earlier we were having only this particular band to be communicated over my telephone lines. Means if I'm going to generate any voice signal, the voice signal is around 3.5 kilohertz to 3.8. So we are going to take it as a 4 kilohertz. And similarly, if I have said something, I have said it to someone, and the other person at the other end of the phone is going to hear these voice signals, and they are going to hear up to a frequency of 20 kilohertz. That's why we usually keep these 20 kilohertz as a guard band also, so that nothing can get into this particular band of the 20 kilohertz, so that we would be able to communicate the voice signal at clarity. There wouldn't be any sort of the ISI or the inter-symbol interference or the inter-frequency interference. Okay, now we are going to use the
Sir,
same
means
line.
here
Yes,
sir, excuse me. Sir, here first 20 kilohertz bandwidth, whatever we have used, that is for fixed, we are using for the audio purpose only.
Yep, correct. Initially, this particular frequency we were using for the 4 kilohertz only for our voice. Then we just come up with a narrow band. So the narrow band just stretched this a bit up to the 20 kilohertz, so that we can provide by means of this voice along with the other this what we can say the 16 kilohertz remaining channels we can use for the data. And that particular 16 kilohertz can exhibit up to data throughput about 128 kbps only. So that's what the problem is. You are going to calculate it by yourself, no issue. You just remember that we were having the 20 kilohertz channel in which the 4 kilohertz is only for the voice. Then how much remaining 16 kilohertz we can think of as a data. Now we are going to provide you a higher data throughput. So what do you mean by the higher data throughput? We have attached a higher kind of the bandwidth on the same channel, on the same link. And what initially we put a bandwidth of 1.1 megahertz. So this is what we were having the convention in, and this is what we have done. We have put an additional band. After putting this additional band, we have asynchronously divided this particular band for the upload channel, for the uploading of our data, as well as for the downloading of the data. For all these uploading of our data, we have restricted this particular frequency. For all the downloading of data, we have restricted this particular frequency. But now start the very first slide, that we need to maintain it as simple as possible. Second, we need to make it affordable. So we were having all the receivers already designed for this particular channel from the 0 to 20 kilohertz. Means whatsoever I'm going to say and whatsoever I'm going to hear over my telephones, I do have those telephone lines, I do have those telephone instruments which can modulate it, which can demodulate such kind of the signals. But what about this? I have put this new signal into it. So what to do now? I do have receiver for this. I don't have receiver for this. So should I make or should I design a new receiver for it? What say, sir? ये सिग्नल हमारे पास में पहले चलते थे, जिसपे अपन लोग अपनी वॉइस भेजते थे. ये जो वॉइस है, वॉइस को रिसीव करने के लिए अपने पास में जब मैंने बोला तो उसने मॉड्यूलेट किया. मॉड्यूलेट करने के बाद में वो रिसीविंग एंड पे गया. रिसीविंग एंड पे जाके उसको डिमॉड्यूलेट किया एंड that's how they are going to recover back my voice signal in its original form. So we do have the modulator, demodulator, sender, receiver for this initially. Now I want to send these additional band of frequency too, and I need to keep my technology financially viable, as cost effective as possible. So should I design a new receiver, a new modulator, demodulator for this band of frequency, or is there any other way I can think of?
Sir, for that remaining channel, we can send by the like time division multiplexing process or FDM base we can send.
हाँ सर, बिल्कुल भेज सकते हैं, लेकिन वो तो भेजने की बात हुई ना. अभी रिसीविंग एंड पे क्या करना पड़ेगा? रिसीविंग एंड पे मुझको रिकवर बैक करना पड़ेगा. तो वहां पे तो TDMA मीन्स I can share my initial resources among a number of different users simultaneously. That's what the access techniques are. My resources are in scarcity. I do have plenty of the users seeking for those resources, so that I can provide my limited resources to the unlimited number of users by means of the TDMA or the FDMA. That's what we usually do by means of the access techniques. But over here, a single user which is sending his or her voice signal initially, we have designed a complete network for the voice signal. We do have the modulators, we do have the demodulators, we do have the receivers, we do have many other things, so that the call rate became very cost effective. Now I want to send my digital signal also. For digital signal, I have put a new band of frequency over the same copper wire, over the same conducting wire. I do have all these modulators, demodulators, receiver, sender for these channels. But what about this? Should I design a new things for this, or is there anything I can utilize the existing one?
I think we can utilize, sir. No need to make something new. Like here we are going for, instead of 20 kilohertz, we are going for the 1.1 megahertz signals. We can consider.
Correct. So how to do that, sir? Because we need to keep our technology as simple as possible, as cost effective as possible. So if I'm going to design a new receiver, then definitely it would involve certain cost. Second one, it should be as simple as possible. And which one is the simplest, most demodulator we do have, or the signal detector we do have? जो आज तक हमने पढ़ा है वो सिंपल से एक AM का है, envelope detector. If there is an AM we are using, then the envelope detector is the simplest, most detector we can think of. Correct, sir?
Yes, sir.
So simplicity भी रखनी है, cost effectiveness भी रखनी है. So what to do now? We do have this particular frequency. So we are going to chop up this particular frequency into this equivalent number of the 4 kilohertz channels. ये 4 किलोहर्ट्ज के लिए तो अपने पास में है ही ना सारा, कि 4 किलोहर्ट्ज की बैंडविड्थ के लिए अपने पास में एक बैंड पास फिल्टर बनाया हुआ है. वो बैंड पास फिल्टर आएगा, 4 किलोहर्ट्ज को पास करेगा, उसके बाद में उसको डिमोडुलेट करेगा, डिमोडुलेट करने के बाद प्रोसेस करता है फॉर द वॉइस. Now over here, if I'm going to chop up this complete band of frequencies into its equivalent number of the 4 kilohertz band, then that particular band pass filter would allow these particular 4 kilohertz channels also. Though there needs to be some tuning, because they are their lower cutoff frequency and the upper cutoff frequency would get changed. But we can think of that, but we can arrange that, because altogether we need not to design a new one. We only need to update our existing one. है ना? उसी में क्या कर देंगे, उसी में एक frequency generator fit कर देंगे. Frequency generator will tune to the frequencies to which number of the bands we are expecting to. Likewise, for the first band, it can tune to certain frequency. For the second band, it can tune to certain frequency. For the other bands, it can tune to certain frequency over a period of time. Because ultimately, it is going to be a sequential transmission. One by one, we are going to send it over the same copper wire. So we can think of, okay, first frame I received, first ATM cell I received, second ATM cell I received, third ATM cell I received, fourth ATM cell I received. For the fifth ATM cells, I can tune my frequency generator. So what we actually did, we have chopped up this complete frequency into the equivalent number of the 4 kilohertz band. And to change or to get away any possibility of the inter symbol interference, because over here we are having one of the channels which is supposed to contain my digital data. Over here it is another channel which is supposed to contain my digital data. So this digital data is nothing but my symbols. So just to go away with any possibility of the inter symbol interference, I need to provide some of the guard band in between. So the effective bandwidth of a channel becomes just a second. Class में. So this is what we do have. So the effect, we are having a channel of the 4 kilohertz as well as the guard band of the 300 megahertz. Oh, sorry, 300 hertz. So the effective bandwidth of a single channel becomes 4.3 kilohertz. Okay, 4 kilohertz का channel है, 300 hertz का 300 hertz का मेरे पास में क्या है, guard band. So this effective number, how many channels I would get? 4 kilohertz के channel मैंने काटे 1.1 megahertz में, so it would be comes around 270 number of the channels. But if I am going to reduce it to 254 number of channels, so 255 number of the channels by using 300 hertz as a guard band. So अभी 1.1 के लिए कितने channels आ गए? 255. Out of these 255, the 32, the initial 8 would be regarded only for the voice. The rest 24 only regarded for the upstream. These are the 24, and the rest around 240 number of the channels would be or less than 240 number of the channels would be only for the downloading my data. And if for the 1.1 megahertz, it would be around 256. For the 2.2 megahertz, the number of channels is going to increase. अभी तक इसमें सर कहीं पे कोई दिक्कत?
नहीं sir. Okay.
So if I'm going to utilize this particular channel for my effective digital communication, so ultimately what is the bandwidth for this channel? 4 kilohertz. If I want to if I want to modulate any digital data into this particular channel having a bandwidth of the 4 kilohertz, that time how to convert or how to generate that digital data? मेरे पास में frequency है 4 kilohertz. So what is the procedure to convert an analog signal into the digital one? First of all, the sampling needs to be done. Correct? And if I want to recover back my signal back into its original form, it needs to be sampled at least twice that of rate of its own bandwidth. That's what the Nyquist usually say. As per the Nyquist criteria, we do have the incoming signal as a 4 kilohertz. So what would be the sampling rate for this channel?
Minimum 8 kilohertz is required.
Sorry?
Minimum 8 kilohertz is required.
Minimum 8 kilohertz. So how many symbols we are getting per second? 8 kilo or 8,000 symbols we are getting. 8,000 samples we are getting after getting the compending, after getting what are the different process. एक तो compending होता है, उसके बाद में क्या होता है कि step size fix करने के बाद में we are going to convert it, उसके बाद में encoding करेंगे. We are using the 8-bit we are using the 8-bit signed codes. So how many we are using the 8-bit signed codes per symbol. So how many bits I can get? 8,000 samples we are getting. Per sample we are using the 8-bit code. So how many bits I can think of? 8,000 into 8 equals to 64K. सही है ना सर?
Yes, sir.
If we are using the PCN, the pulse code modulation, that is using the 8-bit code. So if we are using the simple conventional, the PCM, and we are having the 8,000 samples, so how much data rate I can think of? How much bits I can generate by using this particular channel? 8,000 into 8 equals to 64K. Correct, sir?
Correct, sir.
Yes, sir.
And what about those 20 kilohertz channel? Initially, the 4 kilohertz is for the voice. The rest 16 kilohertz, how much data we can think of? At the max 192 kbps. 4 kilohertz is meant for 64K. 20 किलोहर्ट्ज में अभी कितने हैं 4K के चैनल्स? 4 चैनल्स हो रहे हैं, तो 4 चैनल्स में 64K के हिसाब से कितना आएगा?
$256K.
256 आएगा, but still the fourth channel, as we are using over here the ISI to go away with any kind of the possibility of the ISI, the inter-symbol interference. So we are using the fourth channel as our guard band. So the effective or the maximum data rate would be available in that case is the 192 kbps. Okay, sir. That's why in the narrow band the 192 kbps was there. अभी ये समझ में आ गया ना सर? सिंगल चैनल ये 4 किलोहर्ट्ज का है, 4 किलोहर्ट्ज की सैम्पलिंग रेट एटलीस्ट 8 किलोहर्ट्ज होगा, उससे एक चैनल मेरे को कितना बिट्स देके जाएगा, और हाउ मच बिट्स आई कैन एक्सपेक्ट फ्रॉम अ सिंगल चैनल? दैट इज द 64K. एंड हाउ मेनी चैनल्स आई डू हैव टोटली?
5. Total 5. 4.
नहीं, हाउ मेनी चैनल्स आई डू हैव टोटल? नॉट ओवर ये नहीं, फॉर टोटल 1.1 मेगाहर्ट्ज में मेरे पास में कितने चैनल्स हैं टोटल? अराउंड 256.
Yes, sir.
So 256 into 64K. This is what the maximum data throughput I can expect, including my upload as well as my download. If I am going to have the 24 number of the channels for the upload, the 24 into 64, this is what my upload speed. Similarly, if I am going to have the 220 channels as my download, the 220 into 64K, that would be my maximum download capacity for a broadband having 1.1 megahertz band. Correct, sir? It would be comes around 2.5 mega mbps. So let it be having 256 kbps or more. But for the download, we are having 2.5, at least at the max 2.5. But if you are going to take a number of the other factors into consideration, it would be reduced to 2 mbps for 1.1 megahertz. So if I am going to use the frequency up to 2.2 megahertz, how much data rate I can think of? Initially, for 1.1 megahertz, I am thinking of the 2 mbps download. For the 2.2 mbps, how much data rate I can think of, sir? सर क्या परेशानी हुई अभी?
सर कैलकुलेट कर रहे थे.
सर कैलकुलेट क्या करना? 1.1 के लिए 2 है तो 2.2 के लिए जस्ट डबल हो जाएगा.
Okay.
है ना? दो इट वुड बी मोर देन डबल, बट लमसम में बात करते हैं ना अभी. वी आर नॉट गेटिंग द एग्जैक्ट नंबर्स, बट वी आर अप्रोक्सीमेटिंग द थिंग्स. हाउ मच वाला?
Your voice is breaking, sir. Hello. Sir, there is no voice.
अरे यार, I don't know why we just got disconnected. So are we connected, sir?
Yes, sir.
Okay, so for the 1.1 megahertz, how much data rate we can think of? 2 Mbps. For the 2.2, we can think of just double of it, 4 Mbps. For 35 megahertz, how much data rate we can think of? 70 megahertz. But it would be an approximate value. It is ought to be more than 70 megahertz. And the 35 megahertz frequency we are using for the VDSL. Okay, sir. Likewise, for the ADSL, we are using 1.1. For the ADSL 2 or ADSL 2 plus, we are using 2.2 to 6.6 megahertz. Similarly, for the VDSL, we are using 35 megahertz. Likewise, if I am going to put it up to 1.1 megahertz, how many channels would be there? Around 250. For 2.2 megahertz, we would have more than 500 channels, and in which we are going to distribute asynchronously. So we are going to add more at the download side. We are going to add less at the upload side. And what is there in the ADSL 2 plus? Whenever we are not generating anything, it will automatically use these upstream channels into the downstream channels so that we would get much more speed. That is what we usually do in the ADSL 2 plus. Okay, now here the toughest part comes. So which kind of the modulations we generally use in ADSL? We generally use the dual multitone modulation, though it is one of the type of the QM, the quadrature amplitude modulation. The amplitude modulations are out to be there. For the simplicity of our technology, the amplitude modulations are there. So over here, what we usually do, as we have already chopped up the complete 1.1 megahertz band, and we have just distributed these available bands asynchronously, means about 24 number of the bands as an upstream and the rest to 30 or the 224 number of the bands as of my downstream. All these bands are having the different upper cutoff frequency as well as the lower cutoff frequency. So it would be look like the harmonics of a particular frequency. And that particular frequency usually been around in the center. Before that, I would like to show you something. Just a sec. I'm going to. There would be an application of the FFT and the IFFT. Have you heard about it, sir? The fast Fourier transform and the inverse fast Fourier transform.
Yes, sir. We have heard.
So what it usually do?
It will just find out the DFT of the particular signal, sir. Fourier transform, discrete Fourier transform.
Okay, sir. But one of the technical aspect of this FFT and the IFFT, it usually transpose a signal from the frequency domain to time domain and the time domain to frequency domain and vice versa. That's what we usually do.
Yes, sir.
So whenever we are having a number of the different number of the symbols or digital data, which is running in serially, that time if we are going to calculate its FFT, if we are going to transpose it into the frequency domain, it would have a center frequency along with the numerous sidebands, along with the numerous odd multiples or the even multiples of the same carrier frequency. Over here, the carrier frequency usually resides in the center of the complete frequency band. Likewise, the lowest of the first band would have a lower cutoff frequency, whereas the last band would have a upper cutoff frequency. Likewise, over there, the 25 kilohertz is there and the 138 kilohertz is there. So if we are going to calculate the center of these frequency, it would be comes around 69 kilohertz. Similarly, for the download channels, the center usually comes around the 276 kilohertz downstream. So these are going to be get our pilot frequency. Whatsoever we are going to set our major power, whatsoever the major power we are going to check in our bell-shaped curve, we are going to segregate, or we are going to keep our power nearby to these two frequencies. That's why it is usually termed as the dual multitone frequency or dual multitone modulation, as we are having the two pilot tones, one for the upstream, one for the downstream. So this is how the ADSL usually work. These are the different flavors and the different technical way outs in the ADSL. Likewise, if we are going to use the NXS J, that time we don't use the voice signal. We only use the upload data as well as the download data. So how the ADSL usually works? As I have already briefed you about that, whatsoever the T or the terminal equipment or your computing device is going to work over certain standard, it is going to generate the parallel data. Whereas there is a need to convert the data from the parallel into the serial, as we have only a single pair of fiber. So which kind of the device we can think of? We can think of a device which has the capability to store the data for certain time till the time doesn't come when it needs to be forwarded over the same line, isn't it? And that usually comes around the sequential circuit applications. So we do have the sequential circuits in which we generally use the flip-flops. So one of the major applications of the sequential circuit is our counters, and there are the two special kind of the counters are there. Where we are using these counters, we are using here in the ATUR. These counters are basically working. This the picture I am going to show you. That particular picture is basically pertaining to this ATUR. So we are having these two counters working over there, the serial to parallel converter and the parallel to serial converter. Okay, so whatsoever we are going to generate, that particular data is going to be get generated, and that particular is going to get supplied. If we want to upload anything, that time we are going to get it converted from the parallel data to the serial data, and that's how we are going to convert those particular signals. We are getting the signals. Now we need to put it into the Ethernet frame to the ATM cells. And now the ATM cells is the 53 byte long. So what we are going to do, we have generated a data. That particular data is going to get sampled, is going to be get quantified, it's going to be get encoded, and after these particular quantified encoding, we are using the quadrature amplitude modulations with a 15-bit baud rate. So all these channels are going to be get quantified, sampled, quantified, again encoded, and we are going to get its acknowledgement data streams. That particular data stream is going to be get subjected to the FFT, so that we can convert an equivalent analog signal of it. And if we are going to get the analog signal of my digital equivalent, that time we, by using the FDM, the frequency division multiplexing, we are having the different frequencies, and now we are going to multiplex all these particular frequencies into one, into its equivalent number of the 1.1 megahertz frequency into one by using the FDM, and we are going to generate a 2.2 megahertz and the furthermore. So this is how it usually works. First of all, whatsoever we are getting the data from the network, or whatsoever getting the data from the user is basically generating the parallel data. So now that particular parallel data is coming to this parallel to serial converter, and this particular parallel to serial converter is converting that particular data and converting it into the digital data form. After converting it into the digital data form, we are using the FFT, the fast Fourier transform, to transpose my digital data into my analog equivalent into the frequency domain. And after getting it mapped into the frequency domain, we are using the FDM, the frequency division multiplexing, to multiplex all these different frequencies, having different lower cutoff frequency as well as the upper cutoff frequency, and going to send a comprehensive 1.1 megahertz bandwidth of the signal, or 2.2 megahertz bandwidth of the signal, or much more the 35 megahertz bandwidth of the signal. The procedure remains same. So the coding scheme and its equivalent means its Cartesian representation is somewhat like this. We are having the 16-bit QM code, and it would be look like this. So we are having the 4 bits quite dependent to each other, whereas all these are independent to each other. So we are having, rather than having this 16-bit QM in an approximately manner. So over there, we generally use a Shannon-Hartley theorem. Have you heard about it, sir? Definitely you would have.
Yes, sir.
So what the Shannon-Hartley theorem states, that there are the two scenarios. One is the bandwidth and one is the channel capacity. The channel capacity is the maximum capacity over which a channel having certain bandwidth would accommodate the data. So it is totally depends upon few factors. It can be lower, it can be upper. Likewise, we are talking about highway, and a construction work is going on the highway. So whether it would be the 10 lanes highway, but 8 lanes are subjected to maintenance. So how much effective data rate or how much effective lanes we can think of? Only the 2 lanes we can think of, because at the other lanes the maintenance work is going on. Whereas if the 10 lanes are working simultaneously, then still we can accommodate the 11, 12 or the 13 cars at a time. Isn't it? Just by adjusting few parameters, we can accommodate an extra load also. So the similar fashion, the channel capacity is the capacity of a DTA, or the data transmission equipment, over which it can accommodate a number of channel which is overloaded by putting some extra power. And the channel capacity is totally depends upon the SNR. How much better SNR you can generate. Let it be the SNR would be the 30, and the bandwidth available at your disposal is the 2 Mbps. So if over this 2 Mbps channel, if I'm going to provide you a 30 dB of power, that time how much bandwidth you can think of, how much channel capacity would be there? The 20 Mbps means just by increasing your SNR and keeping your bandwidth as constant as possible, we are increasing our data throughput capability. Isn't it?
Yes, sir.
So this is what we do here. This is our ADSL protocol stacks. We generally use this particular protocol stack, the ATM AL4, the ATM adaptation layer 5, in which it generally only encapsulate the receiving data into the ATM frame format, nothing more than that. It never does anything data manipulation at all. Whatsoever we are going to supply, it is going to be get appended into its respective frame and going to be supplied it to the ADSL physical layer, so that it would be able to communicate. Okay, and these are the two modulations we generally use. One is called as the DMT, which we have already shown you. The other one is the carrier less amplitude phase. So in the carrier less amplitude phase, whenever we are not having any kind of the voice signal, that time we generally use the cap. So this is basically the cap details. This is basically the DMT detail, as well as some other details too. So what would you like to have? Would you like me to share this PPT in your group, or would you like to share this PPT here only?
In group also, sir.
Sorry?
Group, sir.
WhatsApp group.
WhatsApp group. Okay, no issue. I'm going to put it this particular PPT in your WhatsApp group. No issue. So if you do have anything to share, if you do have anything to complain, if you do have anything to suggest, if you do have anything to ask, feel free. Anything you would like to ask, we welcome you. Kindly ask whatsoever the things are there. Amit Kumar ji, Aradhana Soni ji, Chandan ji, Dr. Anil Kumar Soni ji, Dr. Nikita Kashyap ji, Jitendra ji. If you would like to ask anything, if there is any confusion, kindly do let me know so that we would have a discussion over that and it would be a fruitful session rather than being a futile session. We'll share, you will get the PPTs as soon as we are going to log off. By the evening, you will get the PPT. Surely you will get the PPT, sir. Is there anything else I can help you with? If there is nothing, then we can say ciao for today. Very good noon to you. Enjoy your noon. Have your lunch. Enjoy your lunch.
Thank you, sir. Thank you very much.
Yep. Thank you. Thank you from my side. Have a nice day ahead. Thank you.